Hello, today I'm going to take a look at Rust iterators, and I've also installed the GitHub Copilot extension here. Not that one, but how do I see my installed extensions? Yeah, like this. I just click this and you can see that I've installed this GitHub Copilot, which does automatic code completions, and it seems pretty good actually. You get 2,000 completions for free. I haven't paid any money to them. Actually, Microsoft Copilot has already sped up my coding quite a bit. I'm torn between thinking that's really great, and on the other hand, surely if we've got more productive software developers, that means we need fewer of them, which means I've got fewer people to sell programming courses to. But what can you do? Progress is progress. It's inevitable. Okay, so let's take a look at this. Whoa, I don't want that. Let's say let numbers equal, and I do want that, so I'm going to hit the tab key to autocomplete. Now from this, we can actually get an iterator. So I can say let iter, I think I just want this without the mute, equals numbers.iter. And that thing, that object that's returned from the iter method, implements the iterate interface, and that means we can use it to iterate over these numbers, exactly like this in fact. So the iterate interface has a bunch of different methods in, I'm not sure what, but among other things it has a next method which enables this to happen, and it has a count and sum method. Let's run this. So there you can see we're iterating over the vector and just printing it out. So it's the next method that allows this to occur apparently. I can do let, what do I want to say, num1 equal, iter.next, and we'll have num2 as well. So we'll have that. Now there is some terminology associated with this. Let me check my notes because I can't remember it. Well, I've got to change this heading. Apparently methods of the iterator that wind the iterator forward by calling next are called consuming adapters. Because calling next will actually move the iterator. It's not really exactly consuming the numbers, they're still there in the vector, you're just kind of moving the iterator past them. So this is going to consume the first two numbers, and then this loop will now print out the rest of them. However, I think now I will be forced to make the iterator mutable. Let's just try it. So I'll run it. Yeah, and you can see it doesn't work. And the reason is that this object, which whatever it is implements the iterator trait, has of course an internal state. It knows where it is in the vector, and that means it has to be mutable if you want to call next on it. Let's try this. Yeah, I've got unused variable warnings, but that's fine. You can see down here we're just printing 3, 4, 5. But if I add in like a couple of prints here, print, that's exactly what I want. And we'll do it with the second number as well. So if I try this, you can see that we get, what's that sum about? I don't remember putting that in. Oh yeah, well I guess it returns an option, right? So it would have to actually unwrap it if we want to get the actual number. I could put unwrap in there, which I think would be fine. Let's try that. Try this one as well. Yeah, I'm still getting used to this, but you can see it does make extremely helpful suggestions. Let's try that. Yeah, so first number 1, second number 2, and then we got 3, 4, 5. I was a bit puzzled at first why iter doesn't have to be mutable to do the 4, whereas it does to do this. But apparently the 4 is somehow creating its own mutable iterator or something. Whatever it's doing, it can cope with this one not being mutable anyway. Now let me show you count and sum. So I'll say here let sum equal numbers.iterator.sum. There are actually two ways to do this. You've got to apparently specify the type of thing that you're summing, which is I32, that's what's in my vector. And we can put it here with this weird syntax after this sum method. I'm sure it's not that weird. I'm sure eventually I'll understand it, but right now it looks a bit weird. And that works fine. Let's call that sum1. But another way to do it is if I duplicate that line and have sum2, we can just declare the type on this variable I32, and then we're able to remove it here. I might have to do unwrap on those as well. Let's try printing them though for the moment. So print those two and we'll try that. Yeah, no, I didn't have to unwrap them. You can see that in both cases we've got a sum of 15. And similarly, we could do count, like let count equal, let's make this I32 equal numbers.iter.count, and then we can print the count. I'm feeling slightly obsolete here. Okay, yeah, I get this usize thing. I forgot about that. I can't remember what I did to fix it. Did it work without this? Let's just try that. Yeah, it works fine now. Just let it infer the type, and that's fine. We've got a count of 5 items in the vector. It's also possible to modify items while you're actually iterating over them. But for that, we need a different method to get a mutable iterator. So let's try that. Let's do something like for num in numbers.iter_mute, I think is what I want. Let's get that back. Come back. That's what I wanted. iter_mute. And we can multiply it by 2 or whatever. Let's try 10. So of course this is just times equals, but this actually returns I think a mutable reference to each of the numbers. Must be a mutable reference, right? Otherwise we won't be able to change them. And we don't actually have to declare this mutable. I don't fully understand why. Apparently if we were getting plain numbers back from an iterator, which we can do, then it would have to be mutable. But here it doesn't. So we can just dereference it and get the original number and multiply by 10. I suppose as long as the reference is referring to something that's mutable, we're fine. Did I make this vector mutable? I didn't. So we shouldn't be able to change it. This shouldn't actually work. But I think if I put the mute keyword up here, I think it will work. Let's just try that. So if I run that, yeah, so cannot borrow is mutable, but that's just because my vector is not mutable. Let's put this here. And now we'll try this again. Let's try this. Yeah, wait, I've got to print them out or something, otherwise we won't see it. But yeah, so I guess the idea of this is to get a mutable reference, right? And the numbers, the mutability of those is going to be determined by how we declared the vector. But I still don't really understand why don't we have to put mute there, even if it is a reference. But I guess it can just somehow infer the type of that. I mean, we're not declaring it with let, so maybe it's got to do with that. Let's print this. Yeah, I can just accept that, I suppose. Let's try this. So yeah, we can see that they have been multiplied by 10. So if we call a method that winds the iterator forward, that's a consuming adapter because it's consuming the iterator. But let's also look at iterator adapters which don't move the iterator forward. So we've got methods that don't move the iterator forward. So for example, we could do numbers.map, and then we can supply a closure to that to do what we like with them. Let's maybe try adding on 100. And notice I'm not doing plus equals because this is actually going to return a new vector. And in Rust, apparently operations like this are lazy. So I guess iterators are lazy in general, which means that nothing is actually going to happen. This line's not going to do anything unless I call a method that actually somehow uses those values. And what we can do is call collect. So I'm going to ignore that bit of syntax there for the moment, I think. In fact, I'm going to just permanently ignore it. We could type that, but I think we could also just do this. And then we can say let mapped equal that stuff. Now that's not going to quite work by itself, but it almost will. Now let's print it out and try that and see what kind of error we get. So if I run this, yeah, one major thing I forgot is that map is not a method of vector. It's a method of the iterator object that's returned from iter. So we have to do that. We have to put iter in. Let's try again. It's still not going to work. And now the problem is it's complaining about not being able to infer the type. So to fix that, it seems to me the simplest thing to do is to put in colon and declare the type of this variable. And we can put vec, and it's going to be a vec of, and here we can just put underscore and let Rust infer the type of the thing that's going to be in this vector. It just needs to know that it is a vector apparently. Let's try this now. And you can see now it works fine, and we've added 100 to all of them. There's also filter, which is very similar. Let's say let filtered, and again we'll probably need to say vec and put an underscore there like this, equals, and now I don't think we quite need all that stuff. I'm going to say numbers.iter.filter. I'll have all that stuff, and yeah, we are going to want to collect it into a vector, that's true. But here I think I can supply a simpler closure than what the autocomplete suggested. So let's have x, that's going to be each of the numbers, and here we want to return true or false to say whether we want to include it in this vector that's going to be returned. So here I can say x, what's actually in that vector? And we've got 110, 120. Let's say something like x divided by 10 mod 2 equals 0. So if we divide them by 10, I might need some round brackets in there. Divide them by 10, we're going to get odd and even numbers, and then I can just say can we divide evenly by 2 or not? And then I want to print that stuff out. Let's make this a little bit smaller. So just print that, and let's try that. Oh yeah, so this x is a reference to a number. So I do have to dereference that number by the looks of it. Is that what I've got in my notes? I must have. Let's take a look. Yeah, there's my filter example. I didn't dereference it here because I actually gave an example in this document with strings, and I'm just calling the len method of the string. So this is actually the first time I've tried this. Let's try dereferencing it once and see if that helps. Why is it a reference to a reference? Don't know. But anyway, yeah, if we divide this by 10, is my brain malfunctioning? Shouldn't we get 11, 12, 13, 14, 15? Why have I got 20 and 40? That doesn't look right. What did I do wrong here? Should there be 2 asterisks there? Let's just try it and see if that helps. That gives me the same results. I don't know really why. So in my vector, I've definitely got those right. No, wait, that's the mapped one. Nah, what I've got in the original vector, I'm getting confused. It's 10, 20, 30, 40, 50. So if we were to divide by 10, we get 1, 2, 3, 4, 5. And then it's returning 20 and 40 because those are the only even values in the vector. It's returning values from the original vector, of course. We've not done any mapping. We've just divided by 10 in the course of deciding whether to actually include them in the filtered vector or not. So this is actually working perfectly. Not 100% sure what's going on with these, like the double reference and 2 asterisks seeming to work perfectly well. Does it really work perfectly well? A couple of asterisks in there does the same thing as with 1 asterisk. Okay, I don't really understand that. Maybe there's some kind of type inference going on. Anyway, that's all I've got for you today. This AI code completion stuff is kind of frightening in a way, really. I mean, this, to my mind, is an extremely significant change in software development. You can even go to Copilot, and without Microsoft Copilot, without even logging in, you can ask it to write something, and often it will write something that is approximately what you want. Of course, if you've been around for ages and you've been working on the same technology all the time, you'll have a library of code anyway that you can use, your own code. But I think for most software developers, it's really going to speed up what they're able to do. And the same for this Copilot, GitHub Copilot auto-completion thing as well, for that matter. It's really a big change. So, if I'm living on the streets by this time next year, then that's probably why. But let's just hope that it means we can all get more done and we don't have to lose our jobs. Okay, until next time, do check out blog.caverprogramming.com. You can find a write-up there, and you can also watch this video without any ads interrupting it. Until next time, happy coding.